Hi guys, good day. I'm Ashuward P. Claro, and today we're going to solve some problems involving different topics in Calculus 1. So without further ado, let's start and do this activity. In item number 1, find the derivative of the following functions. Fx is equal to sine negative 1 half x. This problem involves the derivative of inverse trigonometric function. And as you notice, it is sine negative 1. Now, we have a formula sine negative 1 u. Derivative of it is 1 over square root of 1 minus u squared times the derivative of u. Now, our u in this problem is 1 half x, and the derivative of u, or the derivative of 1 half x, is equal to 1 half. Now, let's solve this problem. So, fx is equal to sine negative 1 half x is equal to, now sine negative 1, let's use the formula, square root of 1 over, our u is 1 half x, right? 1 half x squared times the derivative of u is 1 half. Next, let's multiply these two fractions. So 1 over 2 square root of 1 minus 1 half x squared. Now, let's simplify this parenthesis. So 1 over 2 square root of 1 minus 1 half x squared is equal to x squared over 4, right? Next, let's subtract this 1 minus x squared over 4. 1 over 2 square root of 1 minus x squared over 4 is equal to, let's see this 4. So 4 minus x squared. Next, 4 minus x squared over 4, let's factor. So 1 over 2 square root factor of 4 over 4, 4 minus x squared over 4 is equal to 1/4 times 4 minus x squared. Next, apply the square root. 1 over 2 square root of 1/4 is equal to 1 half. Square root, copy the 4 minus x squared. We know that 2 times 1 half is equal to 1. So our final answer is 1 over 4 square root of 4 minus x squared. This is now our final answer. Now let's proceed to item number 2. Find the first and second derivative of the given functions. Hx is equal to ln x squared, where x is greater than 1. Now, as you notice, this problem involves a derivative of logarithmic functions. Keep in mind that derivative of ln u is equal to 1 over u times u prime, or the derivative of u. This is the theorem involved to this problem. So, solve in hx is equal to ln x squared. Now let's find the first derivative. So h prime x is equal to, since ln x squared, we can apply the this formula and also the chain rule. So ln, derivative of ln x squared, we have 1 over, this is our u, right? So ln x squared times, inside of the bracket we have 1 over ln x squared. So 1 over x squared times derivative of 2x x squared, we have 2x is equal to multiply. Let's first multiply these two. So 1 over ln x squared times 2x over x squared. 2x over x squared, let's cancel x and x squared. So 2 over x times ln x squared. As you notice that ln x squared is just the same with 2 ln x. Exponent will go to the front of the ln. So we can cancel 2 over 2. So h prime x is equal to 1 over x ln x. This is now our first derivative. Again, our first derivative is h prime x is equal to 1 over x ln x. It's our first derivative. Now, to find the second derivative, as you can notice, we can apply the quotient rule. Remember that quotient rule is u prime v minus u times v prime over v squared. Our u is 1, our v is x ln x. So apply this quotient rule. U prime, we have derivative 1 is 0 times copy the v, which is x ln x minus our u, which is 1. V prime, we have the derivative of x ln x. We have ln x plus 1. How this x ln x derivative of x ln x to this? So just apply the product rule. X ln x, we have derivative of x, which is 1 times ln x plus copy the x, derivative of ln x, we have 1 over x. So ln x plus x times 1 over x, we have 1 since x over x is equal to 1. So 1, therefore ln x plus 1. That's why we come up this answer. Next, we have x ln x squared. So 0 times x ln x, we have 0 minus 1 times ln x plus 1, we have ln x plus 1 over x ln x squared. Since so, the second derivative is negative ln x plus 1 over x ln x squared. This is now our second derivative. Now let's proceed to item number 3. The distance traveled by a car moving along a straight road is given by the equation s is equal to t squared plus 24t, where t is in seconds and s is in feet. What is the average rate of change between t is equal to 30 and t is equal to 80? What is the instantaneous rate of change at t is equal to 30? Now, this problem involves rate of change. Now let's solve letter A. What is the average rate of change between t is equal to 30 and t is equal to 80? Now, let's copy first the position. S is equal to t squared plus 24t. Now, to get the average rate of change, we first substitute the value of t. So first we have t is equal to 30. When t is equal to 30, we have, let's denote it is t1. t1 is equal to t squared plus 24t. substitute the value of t is equal to 30, we have 30 squared plus 24 times 30. So 30 times 30, we have 900 plus 24 times 30, we have 720. So 900 plus 720, we have 1620. Now, when t is 80, let's denote t2. So f t2 is equal to t squared plus 24t. Let's substitute 80 squared plus 24, the value of t is 80. So 80 squared, we have 6,400 plus 24 times 80, we have 1,920. So 6,400 plus 1,920 is equal to 8,320. Now, to get the average rate of change, let's have a formula. Average is equal to the value of t2 minus the ft1 over the t2 minus t1. So area is equal to our ft2, we have 8,320 minus 51, we have 1,620 over our t2, which is 80, minus our t1, we have 30. So we have area is equal to 8,320 minus 1,620, we have 6,700 over 80 minus 30, we have 50. So area now is equal to 6,700 divided by 50, we have 134, and the unit is feet per second. Therefore, the average rate of change between t is equal to 30 and t is equal to 80 is 134 feet per second. Since we already get the average rate of change, let's proceed to what is the instantaneous rate of change at t is equal to 30. To get the instantaneous rate of change, first, let's have first the position. Yeah. To get the instantaneous rate of change, we must first find the first derivative of this equation. So s prime is equal to t squared, derivative t squared is 2t plus 24. Now, since instantaneous rate of change at t is equal to 30, just substitute the value of t, which is 30. So, s prime is equal to 2t plus 24 is equal to 2 times 30 plus 24. 2 times 30, we have 60 plus 24. We have 84 feet per second. Therefore, the instantaneous rate of change at t is equal to 30 is 84 feet per second. Yan. That's it for item number 3. Now let's proceed to item number 10. Find the points of inflection of the graph of the function. Determine where the graph is concave upward and where it is concave downward. Draw a sketch of the graph and show a segment of each inflection tangent. Now this is our function, which is g of x is equal to x minus 1 cube. Now, to find the points of inflection, let's have first g of x equal to x minus 1 cube. Now, let's find first the first and second derivative of this function. So, g of x is equal to x minus 1 cube. First derivative, we have g prime x is equal to 3x minus 1 squared. And the second derivative, we have 2 times 3, 6. Just apply the power rule. Next is x minus 1. Since we know the first and second derivative, let's find their points of inflection. X is equal to, find the value of x. Since x minus 1 equal to 0, x is equal to 1. Now find the y. We have to use our original function. We have g of x minus 1 cube. G of x, let g of x is equal to y. So x minus 1 cube, the value of x is 1 minus 1. Since 1 minus 1 is 0, therefore y is equal to 0. So our point of inflection, 1 and 0. That is our point of inflection. Point of inflection is 1 over 0. Now, let's determine where the graph is concave upward and where it is concave downward. Now, let's draw a table. Now, let x is less than 1 and let x is equal to 1 and x is greater than 1. Now let's go to our second derivative, gx. If we substitute x greater than x is less than 1, so let's have 0. So let's try. Let's substitute 0 to our second derivative. G prime x is equal to 6 x minus 1. The value of x, that x is equal to 0. Therefore, 0 minus 1, 6 times negative 1. Therefore, negative 6. We have negative, right? Therefore, it is negative. Now, let x is equal to 1. G prime x is equal to 6, 1 minus 1. 6 times 0 equal to 0. Therefore, if x is equal to 1, it is 0. It is also our point of inflection. Now, if x is greater than 1, let's have 2. G prime of x equal to 6, 2 minus 1. We have 6, 1, 6. Therefore, it is positive. Through this, we can determine when the graph is concave upward and when the graph is concave downward. Since it is negative, therefore its concavity is concave downward. Since it is our point of inflection, and x is greater than 1, since it is positive, it is concave upward. That is how to determine the concavity of this function. Now let's graph this function. Graph and show the segment of inflection tangent. Now, then the tangent line, the slope of the tangent line at the inflection point is x is equal to 1, is 0, right? 0, which means the tangent line is horizontal. Imagine this is our graph. This 1. Our point of inflection is 1, 0, right? So therefore, ito. And our tangent line is horizontal, meaning this is our tangent line. Ito, tangent line. Therefore, the graph looks like this. Now, let's proceed to item number 11. Evaluate the following indefinite integral. Now, let's try to solve this letter A. To solve this, it is important to memorize those formula. So let's start. Solve in integral 3x squared minus 4x minus 3 dx. Now, the first thing we need to do is to separate, and also the constant will be moved outside the integral. So we have 3x squared dx minus 4x minus 3 dx. Now apply the integral. We have 3x 2 plus 1. We have 3 over 3 since the exponent is 3. Next is minus 4 integral of x negative 3. We have x negative 3 plus 1 negative 2 over exponent is negative 2 plus integral of dx. We have c. Next, simplify. We have 3 over 3. We have x cubed minus 4 over negative 2. We have negative 2, right? Negative 2, since x is has a exponent of negative. Let's put this numerator to the denominator. This x magiging x squared plus c. Therefore, x cubed negative times negative positive 2x squared plus c. This is now our final answer. Now, let's proceed to item number 12. Item number 12 involves definite integral, meaning it has a lower and upper limit. To solve this problem, we have integral pi over 2 0 cos x dx. Now, the antiderivative of cos x, we have sin x, right? Now, let's have the upper and lower limit. To find the exact value, we need to subtract the upper minus lower. Therefore, sin our x is pi over 2 minus sin 0. Now, sin pi over 2 is equal to 1 minus sin 0 is equal to 0. Therefore, 1 minus 0 is 1. This is now the value. Now, let's proceed to the last item. Find the area bounded by the given curve below. So we have y is equal to x cubed with an interval 0 and 1. So to find the area is equal to the integral, which is 1 0 x cubed dx. Therefore, the derivative of x cubed, we have x 3 plus 1 4, x over exponent is 4 and 1 and 0. Now let's subtract the upper and lower limit. We have 1 4 over 4 minus 0 4 over 4, since it is 0 and this is 1 over 4. Therefore, our area is equal to 1/4.